Hi everybody, welcome back to our CSWA tutorial series. This is tutorial number 2 to prep you guys for the upcoming CSWA exam. Today I'm joined by Jacob, a senior R3 mechanical design member who has completed both the CSWA and CSWP professional licenses exams for SolidWorks.
Yep. Um, so I guess we can just get right into it, right?
Yeah, just before we get started, all of the resources and everything that we'll be using today can be found in the link in the description. It'll take you to a Google Drive with all of the files and everything that we'll be using today. So if you need to refer to anything, we'll be using those files.
Yep. So I'm gonna start out with the part design assembly, the part design portion, and then we'll move on to the assembly portion. Hopefully we can fit this all in. So right off the bat, I have SolidWorks open. I'm just gonna go up to the top here, click new, and want a new part. And it's very important that you select your units correctly, depending on whatever the part is required in and what it's dimensioned in. Typically, it'll be millimeters, but if it's inches, centimeters, or something, then you have to make sure that your units are correct because if you can make the part completely correctly, but if you have the wrong units, then you'll get the wrong mass and wrong answer. So that's one of the most important things to check for is check that you have the correct units when you start your part. And also it applies for the assembly as well, but we'll get to that. So if you have the part drawing open, I can slide it over here for a second. So you see all units in millimeters. So I have some millimeters selected and there's a lot going on here, but typically the view with the most dimensions and a cross-sectional view like this will be what you want to start with. So because this part is like cylindrical in shape, uh, my thought process right now is to kind of draw the profile of the part, specifically half of the part, and then revolve that uh, in a circle to make the entire cylindrical portion. So this cross section here has all the important dimensions that we need and all of our global variables that we'll be using. I'll touch more on that a bit later. So I'm just gonna start sketching the basic profile of the part. I'm just gonna select the front plane for this. It doesn't really matter which plane you select, as long as you're sketching on the same plane, pretty much. I'm gonna treat this origin here, this red arrow here, and this orange highlighted dot. This is the origin. I'm gonna treat this as the center line. So going up would be the center line. And I'm just gonna select the line tool up here. Another thing you can do is actually hold right click on your mouse and then you have the radial wheel pop up. And if you hold right click and then go to the left, it'll select the line tool. And that's something I use a lot. It's pretty common. Just a shortcut to um, quickly access the most common drawing sketch tools. So this is your measure tool, but we'll use that later. So I'm just going to start at the bottom of the part for now. So as you can see, it goes out and then up. And then we have this little lip here. At this point, I'm not concerned about the dimensions of the part. It's much easier to draw the basic shape of the part and then go back to it and dimension everything afterwards. So here we have it goes straight up and then there's this curve and there's two ways to do this. The way that I would prefer and is faster, I think, is to do this. And basically how you do that is with the line tool selected, when you draw from a point, it'll make a straight line. But if you go back, hover over that point again, and you see this yellow circle next to the pencil icon, and then you start drawing again, it'll make a curve or spline based on where your mouse is. So I'm just gonna select that here. And it's an arc of a circle that you can move around. So then obviously the other way to do it is you select the circle tool and you can draw a circle. And I'm gonna make these tangent because on the drawing, you can see in the bottom right view that those two surfaces are required to be tangent. So how I can do that is I can just select this line and the circle. So I'm holding shift when I select the circle so I can select multiple lines. And then on the left here, you can see that you can add relations between these two. I'm going to select tangent. This is the important one. These other ones you won't really use very often. I've honestly never used them, so it won't show up on the test either. And as you can see, it's tangent right now, but there's a lot of, it's not defined, so I can move it around. So, but this is the important relation here. This is a green tangent relation. So if I continue this way and then come up from the circle. So this actually drew the line tangent to the circle, but I don't want that. So I'm going to select this green tangent relation and just hit delete on my keyboard to delete that relation because I want this line to be vertical. So I'm just going to select the line and select vertical on the left because that's how the profile of the part is like. So now I have kind of this basic shape that matches the part, but I have all these unnecessary areas. So I'm just going to go up here and select trim entities. And usually I think it's default set to power trim, but if I were to do that, it would delete the entire circle. So I usually always select trim to closest. And what that does, it trims the line until it meets another line. So if I select the outer circle, then everything on the outer circle is deleted and I'm just left with this curve, which is what I want. And you have to be careful because sometimes if I zoom out pretty far, you wouldn't be able to really see that there's like a little bit of this extra line poking out. But we should trim this because we don't want these stray sketch lines out because it'll make our sketch not fully defined and not closable. So I'm going to select zoom in a bit and just trim that. So I'm just going to continue with the basic shape of basic shape of the part. So we have the straight area. I'll bring the drawing over just to kind of show you where I'm at. So this straight area, it corresponds to this area. So now we have this angle and then go straight again. And then that's pretty much the half of the part. So I'm just going to draw an angle here. And then I don't want a curve here. I want to go straight up and then back to the center. So this dotted line kind of helps me realign to the center. At this point, we have the basic shape, but we don't have a closed sketch. So I'm going to close the sketch by drawing the center line back down to the center origin here. And as you can see, the area of the sketch is now gray, which is what we want. It has to be gray in order for us to actually create any features from it. So to extrude, to revolve, anything. But we still have all these blue lines. And for any sketch, just as a general rule of thumb, you never want to make any features from an undefined sketch. You want all your sketch lines to be black, and when they're black, it means they're fully defined. And that's just helpful because if you were to make a feature from this and then accidentally drag something like that, then your feature would be ruined. So I'm going to start here at the bottom again where I started sketching, and I'm going to select the measure tool or smart dimension tool. And the way I did that was just again with the radial wheel. So I just holding right click and then go up with my mouse and then let go of right click. Alternatively, you can just select it up here. So I'm going to select, I'm going to dimension all these lines that I have based on the dimensions on the drawing. And you want to match all the dimensions on the drawing. So here we have from the outside to the center, a radius of 18. So I'm just going to 18, and you don't need to type in like 18 millimeters. SolidWorks already knows it's in millimeters because of your setting here. And then, from this lip to the bottom, it's 15. This thickness of the lip, it's 8. This is pretty simple. I'm just going to go through this pretty quick. And then here we have from the straight area to the center, it's 9. Then we have the curve. The dimension of the curve here is over here on the left. So I should actually dimension this area first. So that would be the height of the straight area. So I'm going to select that point where it ends, because that's the height of the line to the flat area here. This is 6 millimeters. And then if you look here, the radius of that curve is 24 millimeters. So I'm going to select my smart dimension tool, just select the line and set the radius to 24. And notice how it says R24. That's what we want, because if it just had the diameter symbol or just the number 24, it would be the diameter and it would be 2 times as large. And then here we have, it's dimensioned as 75. So let me zoom out a bit and then show this here. We have 75 from this point here to the bottom. So that's here to here. And then we have our first variable here. Well, actually, I can dimension this radius here first. So that's 15. But we have our first variable here called A. That's the angle of this slope to this vertical line here. And as you can see, A is equal to 30. So the way we define that is if I try to dimension this right now. So this is the angle we want as shown on the drawing. It's this smaller angle, less than 90 degrees, instead of this angle or this angle. These angles are all technically valid ways of dimensioning it, but because the drawing shows it like this is the one, and this is the variable that we want to enter, we should draw it like this so that it gives us the same value. So I'm just going to click. Instead of typing in a number, I'm going to type in equals A, and then it's going to have this globe symbol come up, and I'm just going to hit enter. Oops, I selected that arc sign by accident. So equals A, enter, and it's going to prompt me to create a new global variable named A. I'm going to click yes. And now I have to define what A is. SolidWorks already knows that this angle is in degrees because it's an angle, and the default measurement is in degrees rather than radians. So A is equal to 30 degrees if I'm, 30. So I'm just going to type in 30 here. Again, it already knows it's degrees, so you don't have to type in the units. And click check mark. And as you can see, there's this red symbol here next to it. That means it's a global variable. And also, if you look on your left feature manager design tree now, you can see there's a new folder called equations. So if I select equations, there's A equals to 30. So while we're here, we might as well go ahead and define the rest of the variables. We have B and C. So I'm just going to right click on the folder, manage equations. I'm going to add global variable B is equal to 120. If I remember right. Always double check everything that you do. And then C is equal to 50. So, okay. So that actually exited me out of the sketch. So I'm going to go back here to my feature manager tree, just select the sketch that I was working on and click sketch again. It'll bring me back in. So now we have to define this height, which is B. So I'm going to define the overall length of the part as B equals B. Okay, so you actually have to, when you type that in, you have to type in the quotation marks as well. And you can see it'll give you the check mark, everything will be blue, hit enter, and it evaluates to 120 millimeters, which is what we set it to. Click OK, save the value. And as you can see, you know it works when you have that little red symbol next to it. So we have a couple blue lines still. So we're not fully defined yet. We want to be fully defined before we do any features. So we have this and this. So then that would mean the radius of this part and then the radius of this part. So that's over here as the top part here. This would be 12. And then from here, it's actually not on this drawing, not this view, sorry. It's on this view down here, the top view, where you have this circular portion, this large circular portion dimensioned as radius 20. And don't get it confused with this diameter here, diameter 42. If you look closely on the drawing, this diameter is pointing to this imaginary dotted line, which we'll get to later. But the actual, surface part, this line right here is dimensioned as radius 20. So you should be very careful about making sure the dimension you're looking at is actually referring to the part that you're interested in. And you should also be able to recognize where critical dimensions are. So if you find that, oh, I've dimensioned everything from this view here already, but I still have undefined lines. Sorry. Then you should look at the other views to get more information to see if they're missing something, or you obviously go through the same view and double check that you've gotten everything. And a good way to double check that you've gotten everything is to count your dimensions, because the drawings that they give you will have all necessary dimensions to fully define your part. So if you match every dimension, then you should be matching the part exactly. So here we have a radius of 12 up here. And then in this view, it shows us that this diameter, or sorry, this radius is 20. So I'm going to dimension that from center. Oops. And if that happens to you where you accidentally have something selected and then you want to dimension here, let's say I didn't want to actually select this line, you can just hit escape on your keyboard a couple times and that'll bring you out of the tool that you're currently in. And that works for any tool, for a line tool or whatever. So I'm going to dimension this as 20. And now you can see that all our lines are black, and that means it's fully defined, which means that we can go ahead and create a feature from the sketch. Now, I obviously haven't captured all features of the part in this one sketch. For example, this hole, the slot, and these little cutouts. But if you can imagine, it'd be very difficult to try and capture everything in one sketch. You obviously want to try and capture the general shape of the part and as much details as you can in one sketch. But these cuts and this cut here, to me, it's much easier to deal with that afterwards, especially because these cuts look like they're cutting in a up and down fashion versus this view is side to side. So you can't really do any features in the other direction when I'm sketching on this view. So I'll go show you how I'll add those other features after I revolve this sketch here. So to revolve the sketch, I'm just going to go to features. And then we have some options here. Extruded boss base and revolve boss base. This is the one we want. So I'm going to select this. It's going to prompt me to select an axis of revolution. So basically that's asking for the center of the circle that I'm going to revolve around, the point I'm going to revolve around. And the way we sketch this is that this vertical line here is our center line because it's on the origin, as we dimensioned all our radiuses from there, radii from here. So I'm going to select that line as our axis of revolution, and it gives us a preview of the part. We want to select, in this case, we want to select a blind 360 revolve. In most cases, this is what you'll usually use. But I can show you, for example, let's say for some reason we only wanted 3/4 of the part revolved. So we can put in like 270 degrees, something like that. And as you can see, it only goes to 3/4. But we want to create a solid cylindrical piece. So we want to go all the way around 360 degrees. There's other settings here, for example, up to vertex, up to surface, but these don't really apply because we don't have other features to reference from. So we can just do blind. Click the check mark, and we have our base part here, the basic shape of our part. So if we go and look at the drawing now, what are some of the features that we are missing that we can add pretty easily? The most obvious one to me right now is this hole, and then there's a slot here. But this hole is not the same depth as the slot, as you can see. So we want to treat those two separately. I'm going to start with the hole here, this blind circular hole. You could start with the slot and then do the hole. There's no reason why that would be any different. I'm just going to go with this hole first. So I'm going to start by selecting this top face here where that hole is located. And I'm going to start a new sketch on that face. So as you can see, we have a new origin here on this face, centered on the circle here. And I highly recommend whenever you're sketching anything that you should always be normal to your sketch plane. So our sketch plane is this top face here. So what I can do is I can go up here, view orientation, click on it, and it gives us this cube, which a bunch of faces I can select. I'm going to select this top face here, and that'll make my camera normal to the sketch plane right now. If I move around again with the middle mouse, I can move the camera around and inspect all the features. There's another keyboard shortcut you can use. Control, if you hold control and then hit a number key, 1, 2, 3, 4, 5. 5 is the top view. 1, 2, 3, 4 are the front, left, top, front, left, and back view, and the right view as well. And if you also were to select the face and then hit Control +8, that normals you to whatever face you have selected. So we can do it with this face as well. I'm holding Control and I click the number 8 on my keyboard. That normals me to this face. But I'm going to be sketching on this face, so I'm just going to select it and hit Control 8. So now I'm going to sketch the circle. I'm going to select the circle tool from that radial wheel. Select the origin because it's centered on this circle. So select that orange point, click, and then just drag. Click again. There's a circle. And then pretty easy, just dimension the circle to whatever it's on the drawing. On the drawing, let's see, it's a radius of 9. So that's from here. That's from the center to this edge, and that's the radius. But as you can see, I drew a full circle. So if I type in 9, that looks a lot smaller than what's on the drawing because this is a diameter of 9. So if you draw it to a full circle in SolidWorks and dimension it, it'll default to dimensioning it as a diameter. So obviously, if we want the diameter of the actual diameter of the circle, we have 9 times 2. So in SolidWorks, when you're dimensioning, you can actually type in equations directly into the Smart Dimension tool, and it'll automatically calculate that for you. So a radius of 9 is equal to a diameter of 18. And then that's all I need to be concerned about for that hole. And I'm going to go to my features again. And also notice how the sketch line is black, right? That means it's fully defined. So that means I can go ahead and do my feature. I'm gonna go to extrude cut because I want to remove material instead of adding material. And then I'm going to go blind. It's a blind hole and it's a depth of dimension C. So I'm going to go here, select this, just going to type in equals C. So you actually have to type in the quotation marks. That's important. I'm hitting enter right now and nothing's happening. So if I go here, quotation C, quotation, everything's good. Green check mark, blue color text, click check. And we have our blind hole. In the case you don't know what blind means, a blind hole just means a hole that is drilled to some depth, like some specific dimension. A through hole is a hole that goes through the entire part. So a blind hole does not go through the entire part. It ends in just like it bottoms out at some point. So it's quote unquote blind. You can't see through it. So that's the hole there. And next, let's take a look at the slot in the side. So this. So if we drew our sketch here on the front plane. So if we take a look at these drawings, the slot is perpendicular to that plane, right? And so, yeah, here's a good view where you can see the slots. And this is the plane that we drew on, the front plane. So if I select front plane, this is where we drew the first sketch. I'm going to normal to this. So we want to draw our slot on a plane that's perpendicular to this plane. So that would be the right plane here. And I'm going to hold control and then tap 8 on my keyboard. And that'll bring me normal to the right plane. And of course, you could do this with the view orientation tool up here as well. So select that. I'm just moving my camera around a bit so I can see this face. And then select the right plane. I'm going to sketch on this plane. So sketch. Going to draw the basic shape of the slot here. Again, I'm going to use that fancy curve here with the line tool. And remember to close your sketch. This might look like it's a complete sketch, but if we take a look, you can actually see that it's not grayed in. So you have, or it's not connected here, so it's not closed sketch. So you have to connect these two dots and you can see that the area will fill in to show you it's a closed sketch. So I'm going to normal to this plane again. Actually flip the view. So one thing you can do is actually hold control and then hit the arrow keys on your keyboard to rotate the view. Oh, wait, there's a shift. Oh, no, okay. So if you hold control and then hit the arrow keys on your keyboard, it'll move the view left, right, up, down, whatever. If you hold shift and hit the arrow keys, it rotates the view. If you hold alt on your keyboard and hit the arrow keys, you can turn the view like this. So I want to draw it like this. So we can dimension the drawing accordingly. See, slot width of 6, slot depth of 28. So I can just do that, 6. And then if you notice, the dimension is specifically to the center of the circular region. So that's how you should dimension it as well. So from the top here, You notice how this line is shorter than this line? What it's actually selecting is this inner radius. In our case, it doesn't matter because they're on the same level, but it's always good to just select, whatever you're referencing to on the drawing. And in this case, it's the top, the outer edge. So I'm going to reference from that and then select this center point. That's 20. Gonna recenter, re-normal to the drawing plane. So as you can see, we still have blue lines, and that's if you have blue lines but you aren't sure why, what you can do is just click on the blue line and just see how you can move it. So I can't move it up and down, so it's defined here. As you can see here, it's coincident with this edge. But I can move it left and right because it's not defined in any way in this direction. If you look at this view, this top view, we can see that the slot is centered on this direction. So we can just select this dot and then our origin down here, which we know is the center of our part. Select those two and you can make it vertical. And as you can see, now all lines are black and fully defined. Another way you could do this, I just hit Control Z on my keyboard to undo that. You can hit Control Z, I think, pretty much an infinite amount of times in SolidWorks. I think some exceptions it'll stop you, but if you make a mistake, you can just very easily go back. But another way to do this is you can go select the line tool, and on the left here, select for construction, and then just draw a line from this center to this center, and then select the line, and then make that line vertical. This also works. Now I'm going to go to features and then extrude cut again to remove material. And when you're in features, you typically want to actually move the camera around to see the preview, to see what's actually happening. So in this case, we have a blind cut, 50 millimeters. We don't actually want that. What I want to do is go through all. So that's easier because let's say, for example, we have like 5 millimeters typed in for a blind cut. As you can see, it doesn't even intersect with what we want to cut because I drew in this right plane, so it's in the middle. So it has to come out and then cut into this area. So I'm just gonna go with through all because that just guarantees that it'll always cut through the entire part like how I want it to. And instead of doing this twice on both sides to save me some time, I'm gonna select through all both. So that will just do it in both directions of the sketch. Just select OK. Hold on 1 second. Through all both from sketch plane, click OK. All bodies. Oh, sorry. I think I had something else selected. Through all both. Yeah, okay. I think I must have had a extrude selected or something. So we have our cut extrude now. We have our slot. If we go back to our drawing, we need to add, I think the last feature is to just add these circular cutouts here.
Actually,
And
before you get to the next step, I had a really quick question for you.
Yep, for sure.
When you're making those slots,
Yep.
does it really matter if you use the front or the right plane? Would it change the mass, or is it just a good practice thing to do it on the right plane because it's on the right plane on the sketch that you're given?
In practice, I don't, and specifically for this part, it would not change the mass because, it's cylindrical, so it's symmetrical. It's about that center. I think it's just good practice to be like, okay, I drew this on the front plane, so this is the front view. And then if we look at the right view, that's where the slot is located. I should draw the slot on the right view or the left view. The right or left doesn't matter in this case because it goes through the entire part. But if you were to draw the slot, this way, up and down, it's technically still exactly the same. You just rotate the part, but I think it's just in general good practice to draw things how they're shown on the drawing. But if you know, like for a fact, oh, it's a cylindrical piece, I know that it's going to be symmetrical and I can just cut it in any direction, then go for it. But if you aren't sure, then just follow what the drawing does, right?
Perfect. Yeah, I figured it was as much. Just double checking.
Yep. So the way I'm going to do these slots is first I'm going to start a sketch on this face because that's where the cuts are. So select the face and I can just select sketch from this little pop-up menu instead of going up here, going click sketch. It'll automatically bring it up whenever I click on a surface. Again, I'm going to normal to that sketch plane. I actually want the arrow pointing up. That's just personal preference. There's no reason you couldn't draw it like this. So I'm just going to rotate my view. On the drawing, we can see there's this imaginary circle, which is where these circular cutouts are centered on, right? So I'm going to draw that imaginary circle first. So again, from the center of the piece, I'm going to draw the circle out larger than this area here, this perimeter, because we know that it is larger than 20 or diameter of 40, it would be. We have 42. I'm going to dimension that as 42. But this is not an actual feature, right? This is not a physical thing that actually exists in real life. This is just a reference line to get you to position these cutouts. So I'm going to select this line, the circle, and then select for construction. It's purely for setting the position of the cutouts, and it's not a actual feature. So now I'm going to use it to set the position of these little cutouts. I'm just going to draw the bottom one here to some diameter. Okay, radius of 2.5. And I just drew the bottom one because it's easier than drawing one at an off angle. And I'll show you why in a second. Let's dimension this as 2.5. But this is this is a diameter because we drew a full circle. So I'm going to dimension it as 2.5 times 2. Obviously 5 millimeters. Fully defined. But instead of trying to do this like 20 times, it says on the drawing, 18 degrees times 20 equally spaced. This is what this means, equal. It means that each cutout is spaced out 18 degrees and there's 20 cutouts. They're all equally spaced out. There's actually a feature that will help me do that a lot faster. So if I go up here in the top, we have linear sketch pattern. You can click on the drop down menu here and select circular sketch pattern. Parameters, I want to select this as my parameter to basically clone. As you can see, it defaults to 4 instances, but we want 20 instances. So here, it's this icon down here, one with like if you hover over it, it actually tells you, it says number of instances. So 20 and we have a preview of all the things that we're gonna get here. You can choose to select display instance count. This doesn't really matter. What does matter is equal spacing, 360 degrees because we want it to be all around. 360. Yep. So I accidentally selected dimension angular spacing. The way that works is basically this dimension here, 18 degrees. If you wanted to dimension it that way, you could. Dimensioning it that way just means you have 20 instances, each 18 degrees apart from each other. But I think it's easier to just say that there's 20 instances all equally spaced. It depends on how this is given to you. In this case, it kind of gives you both. It tells you, yeah, equally spaced, but they're also, 18 degrees from each other. So it's like redundant information, but that can be helpful sometimes. So you can do it both ways. I'm just going to select it like this. I don't really need to touch anything else on this. I'm just going to select check mark. So we have all our circles now, but notice that they're all blue. So that will usually happen when you try to do a linear or circular sketch pattern. Instead of trying to dimension each one of these as 5, actually it doesn't even let me because it's overdefined. An easy way to do this is just hit right click. If you deselect the drawing, right click, fully defined sketch down here. So under the relations, it'll prompt me, do you want to define all entities or just select certain ones? You can just do all entities and click check mark, and everything is fully defined now. So I'm going to go to features here, and then again, extrude cut, because I'm removing material rather than a blind cut, because this is what happened before. This is what I was talking about before. I typed in 5, but it doesn't go all the way through. I'm going to do you could do a through all cut, which will cut through the entire part. But in this case, it doesn't matter. But pretend that this surface here, this larger circular portion was larger and you did not want to cut that, then this would not be good because you'd be cutting into that part. So I'm just going to select up to next. And what up to next does is it only cuts until it reaches the end of whatever surface it is intersecting with. So I don't even have to type in the exact dimension, this thickness, like I would have to do for a blind cut. If I just select up to next, it just knows, okay, I'm just going to go through until I reach the end. And you can also do that similarly with up to vertex. I think you can just select this. Oops. Up to vertex. There. Well, I guess there's no vertex here because there's no edge, but let's say if it was like a square part, you could select a vertex to cut to. So I accidentally exited out. So I'm going to go back, extrude cut, and just go to up to next. Well, up to surface should work for this actually. Yeah, it's the same thing. Up to surface. But let's say I'm lazy and I don't even know which surface I want to cut to. I just want to cut through this specific area. Just do up to next and it already knows. So there's that. One other important thing that I actually forgot is I think it's actually not on this drawing, which is my mistake. I can add that afterwards. But the material of the part is very important for you to find the correct mass for your test. So on the left here, we have a feature manager design tree, material not specified, right? Anything that's not specified will be in this default gray, SolidWorks gray. So I'm going to select material. And the material for this is actually, I'll put it on the screen now. It should be AISI 1020 steel. So I'm going to select edit material. So I just right clicked on material, edit material. So there's a bunch of different materials here in SolidWorks. Typically, it'll just be like a steel or aluminum, something like that. And it'll be pretty easy to find. So here's steel, AISI 1020. You can change your units if you wanted to. I'm just not going to touch anything and leave it the same. Click apply and then close. The color of the part changed slightly to try and mimic the material color. But the important part is that the density of the material will help you get the correct weight. So let's go double check the drawing that we have to make sure we've captured everything. Let's zoom out a bit so you can see this. So this all looks correct. There's actually this small feature that we forgot. There's a chamfer on the bottom edge here. Whoops. So I'm going to go ahead and add that. Really easy way to do this is just to select the edge that you want to put a chamfer on. Go up here. Instead of fillet, select the dropdown, select chamfer. Obviously, you can use this to do a fillet if that's part of the part. In this case, we want a chamfer. On the drawing, it says 2 times 45 degrees. So what that means is 2 millimeters by 45 degrees. So here, just going to type in 2. 45 degrees already set to that by default. Click check mark, and there we go. So we have our chamfer there. Another way of doing that, if I just Control Z, delete that, we could draw on the right plane or front plane even, doesn't matter for this case. And I can cut out this chamfer with a Revolve sketch, right? So I'm going to go here, just draw the basic shape that I want to cut out. It's 2 millimeters by 45 degrees. So this will be 2. This is 45 degrees. Oops, 45. And then I'm going to revolve boss. We actually don't have an axis of revolution here because we don't have a line here. So I'm going to click cancel. I'm going to draw a construction line to give us a center line to revolve around. And I'm just going to make it, I just drew a line there and then I'm going to select it again. And I'm just going to select infinite length. So I don't have to bother with, setting its correct length. In this case, it's actually not fully defined yet because I haven't set it to the center like it should be. So I just select the line, hold shift, select the origin, and then make them coincident. There, now it's fully defined. And I can go to features, revolve boss base. I actually want to make a revolve cut because I'm removing material. So go to revolve cut. I have this line selected already, so it knows that's the axis of revolution. And I'm going to cut 360 blind, and that's our chamfer as well. That was a lot more steps than just going here, but that's another way you could do it.
I had another
So,
question about that actually. Would it
yep.
be feasible to do it in your to draw that chamfer in on your initial sketch as well?
So on this sketch, right?
Yeah.
Yeah, you could totally do that right here. So you could just draw it like that and then dimension that accordingly. That's totally something you could do. In general, I prefer to add stuff like chamfers and fillets as features later, but that's just my preference. There's not the reason that's my preference is because sometimes you know that chamfer dimension will have to change based on like some other things. But I think in terms of for the test, it's that dimension is that dimension. So you don't have to change that dimension. But it's much easier to change the chamfer feature than going into the sketch and then going to that part and then changing those dimensions. But there's no reason why that wouldn't work. It's perfectly acceptable to do that as well.
Right. Okay.
So now, assuming that we've done this correctly, we're gonna check the mass property to see if we got the correct mass, which is what you would be typing into your SolidWorks test. So here we have, what do we have? A mass of 497.18. So here we go to check that, we go to evaluate. And then mass properties up here. So we actually have a 477 grams. Something is probably a little off here. Let's check our global variables, check that they match. 30, 120, and 50. Okay, those match.
While we're looking at that, we have a question from the chat as well.
Sure.
Will there ever be a case where a material is specified, but a certain property of the material is required to be changed?
I don't think so. I've never seen that myself. Usually they'll just say selected this material, right?
Yeah.
Even like these properties, I'm clicking on it right now. I can't change them. I think you can, like if you go to custom, probably you can probably set certain properties, but typically that shouldn't be on the test.
Yeah. For the purposes of the CSWA and I believe CSWP examinations, they don't require you to change the properties, and it would be a really rare case otherwise as well, unless there's like a specific blend that your company or that you're working with that is totally custom to your company and what you're working with. So most of the time, I would say you wouldn't have to change it. And
Yeah. So I think I actually I didn't make a mistake in making the part. I made a mistake in typing this mass because I'll just show you this is my reference part. If we take a look at the reference part, you can see that C is actually 40 and the mass is 497. So this is not correct. I'm going to change this on my reference part back to 50, what it should be. And this is how you would change it if you had it incorrect. If you found that you had it incorrect, just go to equations, right click on it. I'll do it again to show you. Equations, manage equations, and then you can type in to fix your mistake here. And if we check the mass properties, it's 477, which is exactly what we have. Exactly what we have here,
yeah, so just to
477.
clarify for everyone, we will update this on the document,
Yeah,
but on the PDF file, the mass property shows as 497.18. The correct mass is actually
477.
477.048.
Yes, based on these variables, based on these
Yes.
variables. Yeah, that's my mistake. But you know, we'll resend those documents out. Okay. I'm gonna not go through exactly how to do everything in these next two versions of the part, but I will go through what I think is the important features. So I'm not going to change these variables and check the mass, uh, but I should double check that before I send the document out for you guys next time. Um, I'm going to show you how to do in this one, this slot cut here, because if you look at the drawing, it's on a 45-degree angle relative to the other planes, the front plane, the right plane. So that's kind of weird because obviously there's no plane here that we can select to draw on. So instead, I'm going to make a new reference plane. So the way to do that is you go to features. You can go to reference geometry here, select plane. So we need to select reference planes to define this new plane that we have. But we don't really see any planes here right now. So I'm going to go to here and click on the drop down menu, this eye icon. And I'm going to select on hide/show primary planes. So that lets me see all the planes. So I can select them to reference off of. In this case, it is important where you actually put the slot cut because it's not perfectly cylindrical anymore. In this drawing, you have this small cutout. This is pretty simple, so I don't think I'll go over this. But we want to make sure that this slot is in the correct position relative to here. So this looks like the front, right? We have the other slots on the left and right to it. And then we have this. So let's just say that this is the front view. Um, this section view is actually on the wrong side, I think. But let's see. Let me just double check something. Okay. Either way, this is a little confusing because I think the view it's above, but it's if you look at the section arrows, they're pointing upwards, which means that it would be like you're looking at it from below. So you're looking in the direction of the arrows. So then this is correct in this orientation, this is where the cut is. And it's on the front side on towards the right. So I want to draw my I want to draw my sketch plane so that I can draw this shape on there. So that would be, let's see. We have our front plane here and then our right plane. So we want to draw it around here. So I'm going to make the first reference the front plane. And then I want to select this at an angle, 45 degrees. 45 degrees to the front plane should be what I need. Second reference. Nope. Delete that. So we have a preview of our plane here. Let's see. Select a line. Mid-plane constraint. Okay, hold on.
Just while Jacob is trying to sort that out, there was a question about how many questions would be on the actual exam, and I'll answer that really quickly. Um, there's three major parts. Drawing 3, which will have 3 questions. Parts and modeling, which has a total of 7 questions, and assembly modeling, which would have a total of 4 questions attached to it.
Yep. So here, what I've done is, I'll delete it so I can show you again. I'm going to select the front plane, and I'm also going to select the right plane as reference. And I'm going to select mid plane for both of them. So I'll put my plane in between these two planes, and that would be at a 45-degree angle. This is not the direction I actually want this plane in, so I'm going to click flip offset on one of them. So this is the direction I want the plane to be in, because I want to be drawing on this plane so I can cut in this direction. So I'm going to click OK, and it'll tell me that it's fully defined. I'm trying to see, I think there's a different way to do this as well. If I click Control Z, reference geometry plane, I think there's a way to just type in the angle. So if I set the right plane to 0 offset distance, and then select the front plane to be at a 45 degree, will that work? Sorry, let me just check how I did it in my original part.
Could you maybe set it so that it's coincident and then try to do the angle?
I don't think that would work. Let's see though. No.
Oh, okay.
Okay, but I think I found out how I did it here. Delete everything. Okay, so the way I think I did it was, I want it on this area here. So I'm gonna select, my first reference is this face here that I'm gonna cut on. And I want it tangent to that face. And the second reference, I'm gonna select as my front plane and then set it to be 45 degrees. I believe that should be, yep, there you go. So it's a little different because it's not from the center. It's actually tangent to the surface of this, but that's how I did it originally, and that's how I was intending to show it at first. But the other way I showed you also works. It's just that, let's say you wanted to do a 30-degree angle. This way you could do a 30-degree angle, whereas the other way it was only 45 degrees because it's in between two planes, right? So I'm going to do it this way. It's fully defined, tangent to this face, and 45 degrees relative to the front plane. So it's just called plane 2 now. Um, if you wanted to hide these, again, you could just click that, and then plane 2 here, you can select it and just hide. But we want to draw on it right now, so I'm going to show it. Select it, sketch, and then Control 8 to normal to your sketch. I want to have it vertical, so I'm going to hit Alt on my keyboard and then rotate the view with the arrow keys, just so it's easier for me to see. There's actually a straight slot sketch tool here that will help just draw the slot. Basically, how you do that is you select a point, it'll draw a straight line, and then once you set the length of that line, you can select the width of the slot. So here it's a 6x16 slot. So that refers to, these dimension here. This is 16. And then this dimension here is 6, the radius. But it's not fully defined yet because we haven't selected its vertical position. I think this is actually the diameter is 6, not radius. So when it's called out as a slot dimension, it's referring to the width of the slot, which is also the diameter of the circle. So you should, easier way to do it would be just to dimension the width of the slot. It's giving me an error because it's overdefined. If you find that you run into that error, then you have to delete something that is defining the same thing. Basically, the diameter of the circle is the same as the width of the slot. So I can't dimension both at the same time or it's going to yell at me. So this should be 6. And then these need to be, where is the dimension? Sorry. So I think I made another mistake on this drawing where I didn't tell the person how far up it is. That's my mistake. Yeah, I'm just looking at it again and there's no dimension to tell you where this is relative up and down. So let's just say that it's, 60. And that's fully defined. So that's from the center of the slot. I'm going to extrude cut, and the depth of the cut is actually listed here. So 45 degrees, we have that. It's 5 from the center of the circle. So if we do, let's see, can we offset from, yeah, there we go. So we can do a blind hole. And in this case, we actually have to probably do some math because it's 5 from the center. And then if we know the diameter of this, then we can just subtract to do that. So the diameter of this is, we know is, if I go select this face here, go to evaluate, and then select measure, it'll tell me the diameter here is 30. So if I just go to features, again, extrude cut, and then just do half of 30, so 15 minus 5. That should give me the correct depth. That would be 5 from the center, right? In this case, it's cutting up here because I didn't change the other dimension. I didn't change these variables. But that's basically how you would do a off angle cut at 45 degrees from the front plane. The other thing that you'll probably end up seeing on the test is a multi-thickness shell. So I'll just go to this. I can do it here, yeah. I'm gonna hide this plane so it's not in the way. Actually, I'll just do it on my reference part here because it'll be easier to show you guys. So we can know that. This would be the third version of that part. And then the way we can,
So just before you carry on, there was a question from the previous part.
yep,
Can you please explain the 6 by 16 dimension again? So that would be for the slot. Yeah.
yep. So uh, if I'm to 6 by 16, this is referring to the length of this, sorry, first of all, the width of the slot and the length of the slot.
Yeah. So the 16 is referenced from the center point of the top circle to the bottom circle, which is where you would measure your length from for a slot. And then the 6 is the width of the slot from the very left edge to the very right edge.
Yeah, there's like different ways to dimension slots. It's like kind of a little bit confusing at times, but that's how this one in particular is dimensioned.
Let me know if that doesn't make sense, Jay Champson will try to elaborate a little bit more. In the meantime, there is another question. The
Yep.
hole made near the bottom, what is the angle for the cone shape? So
Oh, this here, right?
yeah,
I can show that quickly on this part. So let's say I want to sketch here to make that flat cut. I'm just going to cut a to a certain depth. Let's see. It is 14 from center. I'm just going to select fully defined sketch because I don't really actually care about these dimensions as long as you know, they're larger than here because I'm doing an extrude cut. I'm going to extrude up to surface. So this surface. So we have our flat that we can sketch on now. I'm going to sketch on this, normal to that. And this is actually this hole. It's diameter 6 and depth of 5. That's what these symbols mean. Diameter 6, depth of 5. The way you would do this type of hole is you can use the hole wizard here. Features. Well, I haven't sketched anything yet, but actually you can exit the sketch. The hole wizard will make a sketch for you. So it's up here, hole wizard. And this type of hole is just generally like a blind drill hole. I don't think they would actually give this to you on the exam because I think they would be much more specific and they tell you the angle of that cone. But this is just like a standard thing that's pretty
used in
common to
practice.
see. Yeah. Uh, any type of hole that's drilled is usually you can use replicate with this hole wizard here. So we have like counter bored holes, counter sunk holes. In this case, just a hole. That's what we're going to look for. So select that. The standard here, this would be given to you. We're going to go with ANSI metric because we're working in metric. Type, dowel hole, drill sizes. You can select the drill size and select the specific size. Let's say we do that and then select diameter 6. And then end condition is blind, depth of, what is it? Depth of 5. That's what this is referring to. And then these options here, near side countersink, we don't want to countersink actually, it's just a straight hole. So I'm going to select that, okay. So you have to select a point on the face to locate the hole. We're going to select this face because that's where it is. So you're going to have this kind of shape that you can use, but it won't, you know, actually exist until you click, and then it'll make the hole. And we only want one, so I'm just going to hit escape to exit out of this. And now I actually want to define where this hole is relative to the surface. So I'm just going to center this hole here. Center this hole, make it vertical, and then put some dimension here. 10. Let's say it's 10. So the black dot is fully defined now. Click check mark, and that'll make our hole here with the cone bottom. You can kind of see it here. And you can do a cross section as well to check. And that's just a typical thing. I just added that in there as like a thing to show what hole wizard is. I didn't really dimension all the dimensions correctly. But I think the harder thing that may potentially show up is like you drawing a reference plane, a new reference plane to make a new sketch on something. Does that answer the question?
Sorry. If you were to actually get a part like that on the actual exam, they would probably give you a bit more specification. They'd tell you it's ANSI metric, or you'd have to assume that based on the drawing saying that it's metric or imperial. And most of the cone settings and stuff like that are by default on SolidWorks. And if
Yeah.
they require to change, they'll probably specify that.
So I'll move on to the shell feature, and then we can take a short break after. I'm just gonna add this hole here and then shell it. Again, I haven't updated these. I'm not gonna check the mass for this one specifically. So I'm just gonna sketch here, draw basic shape of what I see here. So that hole is centered on the circle. And then kind of a key shape. So I'll draw this. And you can select the midpoint of a line. And then I'm going to select the origin and make that vertical, just so it's symmetric. Then going to dimension the circle. Let's see. We have a radius of 4. So 4 times 2, because this is the diameter. And then we have the bottom of the flat part of the key is 8, and the width of the key is 6. So from the center to the bottom, it's 8. And width of the key slot is 6. But we have to go and trim this bottom part to make our sketch fully closed. So I'm gonna go ahead and extrude cut. The depth of the cut is 12 here. So it's a blind cut 12 millimeters in. And now I'm gonna do this multi-thickness shell. So here we have section D here, one typical. So this just means that all the shell thicknesses here are 1 millimeter. Typical just means it applies to everything that's not already specified. And then here we have a thickness of 5. This thickness doesn't change because this is already part of the hole. So the shell doesn't go there. You can see the shell ends here. This would also be 1 millimeter because it's 1 millimeter typical. So it applies to everything that's not dimensioned. So the way we would do that is I'm going to select this hole because that's where the shell like starts. You can see that there's nothing here. So that's where it kind of enters. You can imagine it as kind of like something coming into that hole and then digging all the material out. Select that and then up here select shell. So here I want the first one to be 1 millimeter. Show preview. Then we can select multi-thickness settings. Oh, I actually noticed. So you notice how the preview is showing it coming into this region. I think that's because this hole is cutting into this region because it's not properly sized for this. I'm just gonna move this. So I'm gonna select it and I'm just gonna make this shorter so that it's not intersecting with this area because I don't want it to go in there. So I'm just gonna make this like 10. There, that should be okay now. So anyways, here we have this. So we're at multi-thickness settings, right? So the thickness of the part that's not 1 millimeter basically is 5. So that's what we'd put here for multi-thickness. And then we have to go and select what area, what face that applies to. So that would apply to this outer face here. Be from here to here is 5 millimeters. So if I go and select this face, sorry, this face is selected because I was editing it earlier. It should be this face as face 1. So you can go here, right click and delete this one. I want this to be the first face, and then this is the other multi-thickness face. So if I hit OK, okay, we hit an error here. Diagnosis scope, entire body.
Maybe use the show preview as well, because that'll
All right.
figure out what's going on.
Oops. Shell here. Preview. Huh.
Do you maybe have to select the bottom face of that hole
Yeah,
from the top side?
maybe. Yeah, I think that was it. Um,
That doesn't look.
but I think this should be, maybe if we do, sorry. I think
Okay.
that's it. There we go. Sorry about that. But one way to check once you've done that is to hit the cross-section button up here. So section view. And then you have to select which plane that you want to look at. And we'll try to match whatever is in the drawing here. So I think it is perpendicular to this hole here. So that would be this view. Oh, in this case, well, we actually deleted this wall, which is not what we want. Edit feature, shell outwards. No.
That should be using that one. Maybe there isn't 1 millimeter worth of space between.
Oh, yeah, I think, yeah, hold on. Let me, it might be the variables. Let me update these. The 110, 40. I'm just gonna ignore that. Okay, everything's good.
Oh, not so.
Delete. Um, that work? Hmm. I think it has to do with the depth of this. Is like it's um it's interfering with this as well. I think if I move this further down, probably it'll work. Sorry, this should have been. It would have probably worked if I had just made the part correctly, but I'm trying to save us some time to get so that we can get to the assembly portion.
Someone was saying in the chat that maybe you need to pick a secondary face for the multi-shell part.
Yeah, okay, there.
There you go.
So this is correct now. Basically, what happened was this face was intersecting here, so it couldn't make this 1 millimeter thick. It was like too thin. Um, if you had gone through the whole part process and changed all the variables and done everything correctly, then you wouldn't have run into that issue. But I was in a rush, so but this is how you would do a multi-layer, multi-thickness, sorry, shell. The other thickness part you type in here, and then you have to select which face that applies to. Is there any other questions on that?
We'll give it a couple of minutes in the chat. Really, the moral of the story there is that make sure you follow your drawings really carefully and properly, and you should avoid issues like that. If you try to skip steps and cut corners, it's going to end up coming back at you, and you'll have to spend time trying to diagnose the problem, which will cost you like significant minutes and important minutes during your exam.
Yeah, and I think in the exam you won't even be able to go to the next part
You
until
can go
you
backwards and
answer.
forwards on the exam. So
Oh, okay.
if you really do get stuck, that is an option that you have, but um, you just have to keep track of your time in that case. And the risk there is that if you don't get the right answer, if I'm not mistaken, you do not get part marks.
The like really the most important, spend the most time on the first, like when you're first making the part, because um as I just showed here, like all the subsequent parts will be just adding features to that part. So if your first part is wrong, then everything else will also be wrong.
Yeah. All right. There doesn't seem to be any questions about anything you talked about right now.
Okay.
We will take 4 minute time period, I think, now to just answer any general questions or anything like that regarding previous parts, um, questions about the CSW exam, or anything like that. There's a question here actually. How do we know which faces to select to avoid shelling parts that we don't want to?
Um, I guess in this case, um, basically the way I knew how to select this outer face is because that's really the only face that I can select that's related to this 5 dimension. I can't select anything on the inside yet because it doesn't really exist uh, until I do the shell. Um, if you're trying to avoid, if you see that you shell something and then it's cutting into parts that you don't want it to, like how I had it like cutting into this area, really it shouldn't do that if your part is made correctly. Like when you select the correct face to shell, it should just do everything automatically.
Yeah,
So you might just want to check that all your dimensions are correct if something looks different from the drawing from what you have.
I will say this as well. The way the shell, just to add on, is that the way the shell tool works is that it'll look at what you're referencing and then kind of see where that leads up to. And then the first part that kind of would interfere with what can be shelled is where it'll stop. So if you go back to the preview on the shell, Jacob, so the way here is at the top, it notices that um, since you have that shell 5 millimeters away from the outer edge wall, that shell would interfere and act weirdly with the top face of, or the bottom face of that cutout from the top side. So it intuitively kind of knows that, but you can play around with that and select multiple faces for your 1 millimeter dimension in this case, and play around with that, and that'll change what you're referencing and where you want the 1 millimeter shell to come into play, if that makes sense.
Yeah. And like, let's say, for example, I think a more obvious example would be like, instead of having this cylindrical face as the offset, it would probably look like something on the test. It would probably look like, this face would be 5 millimeters or something like that. It would look like that. And then like this would be dimensioned as 5, this thickness. If we're okay, I can go straight to the assembly part. Um, I think it should be pretty quick.
Yeah,
If any questions come up, feel free to stop me. Okay.
yeah, I think we'll do that too. So just so everyone knows, we will be ending off at 8 o'clock, which is why we're rushing a little bit today. If you have any questions, please feel free to keep using the chat and we'll answer them and make sure that every question that we can get to is answered.
Yep. So just gonna delete this. I have these parts here that I'm going to just open all of them. So I can select them all and just hit open. Okay, put your nice colors. Um, so there should be this assembly doc that I have. They should be available to you that will detail kind of all the mates and the rules that you have to follow for all these parts. And it shows the assembly here. So, these are just general instructions to help make the parts. These are kind of the rules that you will have to keep in mind that are important to mate the parts because they will give you instructions on how parts should be connected generally, but they will not tell you exactly how to do that. So for example, pins are mated concentric to linkages. That's referring to these green pins to these purple linkages. Shaft is mated concentric to bearings, just general rules like that. It's pretty simple mates. So I'll just go into this. First of all, just looking at the image, to make our assembly, we'll want to put the first part that we put into our assembly will be basically our reference part. So we have our XYZ coordinate system here that we're supposed to measure the center of mass to. So I'm going to put in this first red bearing as our uh, first piece in the assembly. So here, I'm just going to go to the bearing and I'm going to make assembly from part. And you can just click anywhere on the screen and it'll put down the part. The very important thing to note is that the coordinate system of, if I go here and view coordinate system, the coordinate system of the actual assembly, which is this thing here, is not the same as the coordinate system of the part, depending on how you put it in. You can just mate those two together and make it the same, or you can set it to be the same. But I'm going to show you what I would recommend to do, and in a second here, once I get all the parts in. So I'm just going to throw in all the parts that I have. So you can select their folder, or you can, probably a better way is to go to assembly and insert components. So we have our bearing. We need 2 of these. So I'm going to put that in. Can do that again. Linkage. We need 2 of these. Just going to stick them in here. Sorry. It probably makes more sense to build it step by step. So I'm going to delete these. The next part we actually need is this yellow shaft here. So I'm going to insert components. I don't actually have it open, so I'm going to go browse, practice assembly, parts, shaft. So there that is. The first component we put in is fixed because it's our reference component. So I'm going to go ahead and just mate these parts. So these are concentric to each other as described in the document. Shaft is mated concentric to bearings. I'm going to select this surface and this surface, these 2 circular surfaces. And then we get this little pop-up menu with a bunch of mates on it. Or we would do this and then go up here, select mate. In this case, it already knows that it wants it to be concentric because they're 2 circular surfaces. Generally, that's what you want. So it already defaulted to being concentric. So I'm going to select OK. And then we'll do that with the other bearing as well. Might as well. Concentric. OK. So all pin and shaft end faces are coincident to the linkages and the bearings. So what that means is that the end face of the shaft is coincident with the end face of the bearing. And the same goes for the other side as well. So I'm going to select this and these 2 flat faces. And SolidWorks already knows that it wants to be coincident. If you're in the mate tool, it'll automatically move the part for you. But sometimes the thing that you want isn't what SolidWorks defaults to. So just make sure that whatever you're mating is what you want it to be. So I'm going to do that on the same side here. Sorry, select this face, coincident. So I'm not in the mate tool right now. That's why it didn't automatically move itself. But you can see on this side, this isn't constrained. It can rotate still. And you want your assembly to be fully constrained. Otherwise, you might be measuring the wrong part or something. Or your center of mass might be off because let's say you accidentally moved the part just like a tiny bit like that and you didn't notice because it wasn't constrained. Your center of mass would actually be slightly off and you might get the wrong answer when you type it in. So if we want to figure out how this is constrained, we can go read our conditions again. And it says the flat side faces of the 2 bearings are parallel to each other. And that's also shown on this drawing here. So this face is parallel to this face, and these are also parallel. So I'm going to select this face and this face. And we have these 2 straight lines, which means it's parallel. Select that, and you can see it turned to make them parallel. And if I try to click on this and drag it, it says selected component is fully defined. It cannot be moved. That's just a good way to check that all your stuff is fully defined when you do finish your assembly. And one thing is that you can actually rotate these shafts if they're concentric to each other, what you can do in the mates. So if I go here to these paper clips, select the drop down menu for mates, I can view all the mates that I've already done. So there's concentric mates, there's flat coincident mates. I can select concentric and then select lock rotation if I right click on it. I don't think you'll actually have to do this because it would not change your center of mass at all because it's a cylinder, a perfect cylinder. So uh, it doesn't matter if it's rotated one way or another, the center of mass stays the same. This would be relevant if there was some sort of cutout or feature on this cylinder that would have to face a specific way. Then they would tell you how it's defined. But in this case, I'm just going to leave it because it doesn't matter. Next up, we're just going to build it from the ground up because that to me makes the most sense. So we're going to go to these blue slider parts. Pretty similar to how these bearings are mated, just concentric and then parallel to each other. So I'm going to go insert components again. I'm going to browse for my parts. If you don't already have it open, so if you want it here, you should just open the part document beforehand, so I can show you that. I'll just open the slider and the linkage as well because I don't have those open yet. Oh, I actually do have the linkage open. Okay, but go back to assembly. I can browse. Oops. It should show up here now. Yeah, slider. There's one. I'm just going to add another one. So this, concentric to this concentric to this. These are parallel to each other. So it moved it, but it can still slide along. These are parallel. And that just makes it so I can't rotate it in this direction. I'm going to turn off these origins for now.
So I have a question about the parallel stuff actually that I think is a pretty common mistake that happens.
Yep.
Why did you avoid making them parallel to each other, the
Oh,
sliders?
okay. Good point. So if I go ahead and delete these mates, if I make these parallel to each other, what happens is they're relative to each other, right? So these can rotate because they're not constrained by our base part here. Basically, everything should be connected somehow to this base part, or some way to fully define this thing. So in this case, we can rotate it about the shaft because there's nothing telling SolidWorks to say that this should be, straight up, basically, or parallel to this. So what you could do actually is you could do this mate parallel to each other, and then you can just mate one of them to this, and that would make both of them straight. That's also something you could do. And now you can see I can't rotate it at all. It's only able to slide because I haven't constrained it in this direction yet, but I will soon.
Awesome.
So that's a good point. Yeah. So now I'm going to go to add the linkages, like these purple linkages here and these green pins. Linkage here, and then another one here. So these parts aren't symmetrical. There's a side that's longer, so you'll want to be careful of how you mate them. If you look at the drawing, you can see that the thicker end of the linkage is at the top here. So I'm going to make these concentric first, this hole and this hole concentric. And if I look at the drawing, sorry, we can see it's on the left of this linkage because I'm using this as my reference point because this is where the coordinate system is. And that's what, this is my first part here. You can actually see the order that you put the parts in as well on the tree. So if you don't remember, for example, like if you switched your view, and you want to be like, okay, what's the first part that I put in? It's this one right here. So these are concentric to each other now, these holes. But this also needs to be coincident to this face so that there's that. And we're going to do the same thing on the other side here. Concentric. Oops. Stuff gets weird when it's not fully constrained, but so because I, added these parts one by one and they come in basically in the same orientation. But if we look at the drawing, we see the flat side of the other linkage here is facing towards us. So that means the larger side is facing away from us. In this case, we need to flip this, part basically. So a way you can do that is if you have a concentric and you notice, if you have the concentric mate and then you notice that the part is facing the wrong direction, you can go right click on the mate and just click flip mate alignment. And that'll flip the part so that the other side is, aligned to what you set it to. And I don't want to make it coincident to this face. We can see that it's covering the blue slider. So we want to make it coincident to this face here. Like that. And we can kind of double check because we can see that these two faces here line up pretty well.
There's a
Oops.
question about assemblies and bringing parts into an assembly.
Yep.
When a part is brought into an assembly, you get the following prompt. Do you want to proceed with feature recognition? What
Oh,
does
okay.
this mean and what should we do about that?
That's just the, I think if it's a different version of SolidWorks, I think it just it does that thing to basically double check the part. I believe they actually tell you
On the paper
on
exam
the
to
paper,
press no.
yeah, just press no. It doesn't really change anything, but they tell you to press no, I believe.
Yeah. From what I understand, all it does is it takes the part, since you didn't make that part, it takes it and it asks SolidWorks to just double check that technically everything exists and works within the rules that SolidWorks has for itself in part design and modeling, and makes sure that it works that way and that it can, in a sense, accurately represent that to you. Uh, and as far as I understand, 99.99% of the time it's going to work. So you can almost always press no. And if it doesn't show up the way you're expecting it to, either that normally means there's either an issue with the part itself or the file format. So you can then try doing feature recognition or figure out if maybe the person who gave you that part or where you got that source from, that something needs to be adjusted.
Yep. So I'm gonna go ahead and make these two holes concentric to each other. And in case you don't know, concentric just means when two holes their centers are aligned to each other. So they don't necessarily have to be the same size hole. So you could have this hole concentric to this shaft. It's just, they wouldn't really fit together, but you could do it in SolidWorks because it doesn't care about that. And so now we have basically our assembly here, and we need to insert the pins as well. So, oops, didn't want to open that. It's going to insert pin. We need 3 of these pins. So I'm actually just going to select the pin in the tree here and then hit Control C and then Control V to just copy paste the pin. It can be a little faster if you have a lot of parts, a lot of the same part that you want to use. So if we take a look at our document, we see that all pin and shaft ends are faces are coincident and they're all concentric. There's an exception for the middle pin here. And I'll show you that in a second after I do these 2 pins. I'm just going to select this, the circular surface, concentric, and then make sure that these are coincident and the pin length is set so that it's coincident on both sides. Oops.
So just another comment, and it's not super important, but just for people's curiosity. I noticed that you're using the circular faces or the rounded faces for your concentric mates.
Yep.
Can you use any circular face or feature, or is there a specific
Yep.
reason?
You can use the circular edge. So if I can make these two, and that'll be concentric as well. You can do an edge and a surface. That'll work as well. Uh, there's no real reason why. For me, I just prefer selecting the surfaces because they're larger and easier to click than the edges.
So
Because you have
just
to.
basically less prone to error.
Yep. So these are this pin here is concentric, so I can do that. But there's a special note that says middle pin connecting the two linkages is this pin's end faces are mated equidistant from either linkage face. Basically, that means that you can see that this pin isn't long enough to be coincident with both sides of the linkage. So it wants us to put the pin in the center of these two faces. And the way you can do that without having to do like any math or anything to set a distance, you can just select this face and this face, which you want to be equidistant, and this face and this face, and then go to mate, and it'll give you this width uh, mate. So I'll show that again because the way I usually do it is just select the faces, and then this will pop up, this symbol, this width symbol. You can see it's like two planes and then something in the middle. Just select that, and it'll move the pin so that it's equally spaced between the two faces that you selected. So we have all our parts in our assembly now, but we can still move this slider, which we shouldn't be able to. We want our assembly to be fully defined. In other words, no other parts can move. So we have these two dimensions here, or a dimension from the end of this bearing to the start of this slider is dimension A. And then the angle here between the two linkages is angle B. I believe that's here. So A is equal to 85 millimeters, B is equal to 75 degrees. So that's also going to be a mate. I'm going to select mate, select the two faces I'm interested in, these two faces. See how it automatically went to coincident? I actually don't want that this time. I want to select the distance mate here or here as well. So I'm going to select distance. The distance is 85 millimeters. Let's double check. Sorry. Yep, 85 millimeters. So then click check mark. Now I can't move this slider anymore. It's fully defined. Can't rotate it, can't slide it. This slider I can still slide because it's not related to this one here. So, but we still have one more mating condition here. We have the angle between these two linkages. If we control that angle, then this also shouldn't move. So select these two faces. And again, we have a pop-up of all of our mates, or you can go to select mate here. And here it automatically tried to make them coincident, but we don't want that. We want the angle between them. So go to select angle, and then we set 75 degrees to be our angle. So there, just moved it. Click OK. Can't move this now. It's fully defined. So now we have our assembly completed. However, the really important part about this is that if I bring it up, it'll ask you what is the center of mass of the assembly in millimeters in this case with respect to the coordinate system shown in the image. So it shows you this coordinate system here, but that's not necessarily the same coordinate system as, sorry, same coordinate system as the assembly's coordinate system. If I show this origins again, this thing here, which is not connected to any part, this is actually the coordinate system of the entire assembly. So if I were to go to evaluate in mass properties, this is my center of mass relative to this coordinate system, the default coordinate system. That's what this is. It's the coordinate system of the entire assembly in general. So what I could do is unfix this part, float. You could float it, and you can see everything else moves with it because everything is referenced to this part basically. And then select this, make them coincident to each other. But I actually don't know which direction is X, Y, and Z when I do this. So what I prefer to do instead, gonna hide these and then gonna fix this again, fix, so then I can't move it. What I prefer to do is actually just insert my own coordinate system. So I go to assembly, reference geometry, go to coordinate system. I'm here, it gives me a random coordinate system to where the part is for the assembly. I'm gonna select where I want it. So in the image, the origin is at the corner of here. And we have X going the length, Y going the width, and Z going the height. So I'm gonna select this point as my origin. As my X axis, I'm gonna select this line as a reference. So it's going that way as my X. My Y, I'm gonna select this line here. My Z here, my Z and my Y are flipped, right? So I can just click reverse the Y axis direction. It'll also reverse the Z axis direction because this is how a coordinate system would be for your right hand rule. So there we have our coordinate system, X, Y, and Z in the correct orientation that we want. So click just OK. It'll give it a name. You can name it whatever you want. So when I go to, and also this is relevant because the document says to what is the center of mass in millimeters. So you should double check your units when you open these parts and assemble them together. In the assembly, your assembly units should be millimeters because when you go to evaluate and go to mass properties, it'll tell you center of mass and then it'll tell you the units. So just make sure that you're matching whatever units you're supposed to. So here we have our center of mass, right? But you have to be sure to look up here and say that it says report coordinate values relative to which coordinate system. The default coordinate system is this guy here. It's still reporting to this default coordinate system. I wanted to report to this coordinate system that I just made. So I'm going to select on the drop-down menu and then select the name of that coordinate system. In this case, it's coordinate system 1. And now this should be the correct center of mass of my assembly relative to my coordinate system 1, which is what this image describes. So let's see if I'm close. 197.79 and Y of 60 and Z of 62.39. So yep, I got it right here. And again, it's important that you actually define the coordinate system correctly because let's say I made this direction Y and this direction X, then these two would be swapped. These two would be swapped, and that might actually be one of the choices on the
Exam.
multiple choice exam. Yeah, and so you might just pick the wrong answer by mistake. I usually think that they're not tricky like that, but they might be mean.
You can never really tell with exams.
Yeah.
We have a quick question from the chat.
Yes.
Why is the assembly underdefined on the bottom right?
That's because of these things. So I think if I go through and were to lock all of the concentric mates that you can see, look at the coordinate system here. I'm rotating the pin. It's technically not fully defined, but because they're just, you know, simple cylinders, pins are don't have any features on them, the center of mass will not change if I move this. Like for example, right now, uh, coordinate system one, this is, right now I have selected the shaft, which is why it's a different number. So what I should do is select, I just exit out and then deselect the shaft. So I can just click on the background to deselect whatever I have, or I can hit escape on my keyboard. Go to mass properties, yeah, rebuild. Make sure you have the assembly selected. So you may want to name your assembly and save it. I haven't saved my documents at all during this tutorial session. When you're doing your test, make sure to save your stuff because you could very well lose your progress if something crashes. So make sure to consistently save. Um, but yeah, so let's see, like this pin is facing that way, same coordinates. If I were to move this pin, let's say rotate that way, rotate this, rotate that, measure again. It's exactly, oh, I have the pin selected again. Hit escape, mass properties, rebuild. It's exactly the same center of mass. So in this case, it doesn't matter, but I think if you want to be like extra sure that everything's defined, you can go to your mates and just select lock rotation for all of them.
Yeah, that's something really important to keep an eye on. It's good that you caught that because there can be really tricky parts or parts that need to be at specific angles, like the linkages that you need to just make sure are in the right orientation or with the right connections or the right mates, or even if they need to be fixed or not. So it's important to keep an eye on, but um, there will be cases where it's inconsequential.
Yeah. So I just went through and clicked on all of our concentric mates and clicked lock rotation on all of them that I could. And now you can see it's fully defined. I'm pretty sure on the test, they will just give you something like this where you have pins and you have to mate the pins, but they won't tell you to lock rotation on the pins because it wouldn't matter.
Yeah, I
But
think.
if you want to be extra sure, then go ahead. It takes like 2 seconds to right click and click rotation, lock rotation.
Yeah, I think the only case where they really are finicky with that and where I've seen real struggles is if they give you a ball joint and you need
Right.
to make sure that the angle of the linkage attached to that ball joint relative to another face or line, um, the angle to that is specific or something like that. That's where that you really need to worry and make sure you should fix rotation and
Yeah.
double check your mates there really, really carefully. That can be a really tough spot to catch
Yeah.
yourself making mistakes.
I would also recommend that you do lock rotation after you've put everything together because you could end up in a situation where something's locked and then you want to move it after, but then it'll this you like you want to mate something, but it won't let you mate it because it's overdefined. So I would say just don't over constrain everything at first. Just lock the rotation after you've put everything together, just to be safe. Because I feel like you can run into a situation where you over define stuff. Like for example, um, I can over define this assembly right now by saying I want this face to be 100 millimeters from this face. It won't let me do that because um, I can add this mate and break other mates. So basically override what I have, or add this mate over define the assembly, which will give me an error. So you don't want to do that. But basically this doesn't work because one, this distance is already defined because there's an angle here constraining it from moving left and right here. And also like 100 millimeters is not even the correct distance from here to here. So it wouldn't work anyways. If I try to say add this mate to break other mates, and yeah, you see, it's messy. It gives me like 100 warnings. So don't do that. If that comes up and you're not sure why, then you have to go back and look at your mates and see, okay, what is actually what do I already have like that's telling it to not move in whatever direction. Yeah.
Yeah, I think that's pretty much everything that we had planned to cover for today. And we'll look to start wrapping up now. If there's any last minute questions or anything like that, we'll stick around for another couple of minutes and deal with those. Otherwise, we will be ending off this stream very soon.
Yeah.
No problem. It's our pleasure. Someone's just saying thank you for the tutorial. Honestly, it's
Yep.
a huge thank you to the 3 team members who took the initiative to volunteer and say they wanted to do these tutorials for you guys just to help you guys a little bit more prep for these exams.
Yeah. And I will say that you guys are like getting a really, really good deal on doing the CSWA. Because I think when I did it, I think it paid over $100 or something for it.
Yeah, it's like $150 if you do it independent of an organization.
Yeah.
So it really depends.
You guys are paying like what, $30?
$45,
Forty.
$45.
Yeah, that's like well, less than half of what I was paying.
Yeah.
Um, and I think it is a really good thing to have on your resume. I think it basically got me my job for like the my internship third year after
Yeah.
third year.
I've had interviews as well where they specifically asked if I've got it or not, and I've always had to say I'm working on it. I'm working on it. And I felt so bad because I know there's other candidates who have it, and some of them even have professional level licensing. So I'm a fit bit far behind on that aspect.
Yeah. And it's just like even if you are fairly familiar with SolidWorks, there's a few tips and tricks here that are like pretty useful. And doing the test just kind of gives you something you can point to, be like, yeah, I know SolidWorks.
Yeah.
And also, it doesn't just apply to SolidWorks; it's just general 3D CAD.
Hmm.
People, like, employers look for a lot.
All right. There doesn't seem to be any questions in the chat, so I think we'll call it a night there. Thank you everyone for coming and listening and watching. I hope you found it super informative. We will be updating the yeah, Shrifty, we can help you with that. I will just finish what I was saying, then just type out your question, what your issue is, and we'll get you sorted out really quick. Um, I was just going to say we will be updating the documents on the Google Drive in the link below. So if there was any confusion with the mass and everything like that that we encountered today, those will all be sorted out. And if you continue to have any of those issues, feel free to email the team at r3@ryerson.ca, and we will look into it and either sort it out or let you know what's going on there.
Yeah. Uh, yeah. Those. Sorry about those little errors. These assemblies and parts I made myself, so that was bound to happen. Is this someone having a issue, you
Yeah,
said?
so I just saw the message now. I try to browse for parts to add to an assembly. I get an error from SolidWorks when you try to do that. Okay. The first thing I will say, and this is a really easy mistake, especially when you're a little bit newer to assemblies and SolidWorks in general, make sure you saved everything properly and it's not still in a zipped folder. Make sure
Yeah.
you've extracted all the parts, everything like that. For the purposes of this exam, I would definitely recommend um, creating a folder or something on your desktop or where you know for sure you have the memory space to save your parts and everything like that. Do you think there could be any other reason, Jacob?
Um, SolidWorks is very picky about where your parts are and where your assembly are is located in terms of your like the file location. A really easy way just to avoid any headache is just to save your assembly file in the same folder as all your parts are in. Because like if you move a part, if you move any file, like a part or assembly file, then when you like let's say when the assembly is closed, when you reopen the assembly, it's going to try and look for that file in the same spot, and it's not going to find it, and it's going to give you an error. But I don't know if that's related to your problem specifically right now.
Yeah, the biggest error when it comes to assemblies, I found in my experience, especially in a team setting where you're sharing files constantly, is where files are located. Because the issue is when I click browse, it doesn't even open the file explorer and right away gives me an error. Oh,
Oh, that's strange. So you click browse and then you get an error.
hmm.
I haven't seen that before.
I encountered something somewhat similar. I've not encountered that specific issue before, but for
Can
me,
you, sorry, go ahead.
yes, for me, my hard drives are really full of a lot of data. So I run out on space on one of them, and it literally says like 0 bytes. So if I try to do anything that requires uh, that specific drive, for example, SolidWorks, if I try to start SolidWorks on that drive, it starts to fail and crash. Um, I would maybe double check that you've got space on all of your drives, if you have multiple or on your specific drive. If that's not the issue, I'm not totally sure what else it could be. Jacob, do you have any ideas?
I don't know, but could you try opening the folder that you have all your parts saved to and just drag and drop it into SolidWorks because that works as well. If
Yeah,
that doesn't work for you, then I don't know what's
more
happening.
than likely you've saved the part wrong, or maybe just try saving and restarting your SolidWorks. Um, if you keep having this issue, please email the team. I we do have prior engagements that we have to get to, so I do have to. As long as all the parts are open, I just select them from the menu. Yeah. So you can totally avoid the browse option if you've got the parts open
Yeah.
already on
Yep.
SolidWorks. If that's the only issue, I'm not sure what's going on with that specific function. Maybe there is an error in the installation of SolidWorks or something like that.
Yeah.
You could probably Google it and find I've never encountered that problem myself.
Yeah. There's
Um,
there's a bunch of different ways to bring parts in. So if you have the part open already in SolidWorks, like I have here, all the parts, you can click insert components and then just select it right here from this menu. You can click the browse feature and then open the folder and do that, or you can have the just go to Windows Explorer, open the folder there and just drag and drop. Like I use all three of those all the time.
yeah, that should at least get you by for the exam if you can't get it sorted out by then. I'm not sure if you're writing it tomorrow or on the second date that we have available. Um, I hope that kind of sorts that out. And if that's it, I think we will have to end the stream here. Thank you, everyone, for joining us. Thank you for your questions. We hope we're able to help you out with anything that you had. If you keep having this issue, Swifty, please just email us and we'll try to sort it out with you as we can and guide you as much as we can through that. All right, no problem. Glad to help. All right, with that, I think we'll call it a night. Go enjoy the rest of your nights, everyone. Make sure you study lots and lots. And good luck.
Yep. Good luck, everyone.
All right, we'll see you all later. Thanks for coming. Bye.
Bye now.